We start with your spinal cord. And if you remember, from the spinal cord, do you see exact, do you see the spinal nerves? Spinal nerves, they include sensory, vegetative, and motor portion. Do you see motor and sensory portion? They produce somatic part of the nerve system. No, vegetative, it completes into each spinal nerve for control of trophism. And each spinal nerve, it is mixed. If you remember, spinal cord continues above and from back opens, do you see, directs to sides, but the posterior part, and the anterior part will be pressed to the back. Anterior part of the gray matter will be pressed to the back by olive nucleus, by pyramids. Do you remember? And because, do you see, all nuclei which were located in the spinal cord like butterfly shape will be pushed to the dorsal side of the medulla oblongata of the pons. This will be one moment. And the new structures, they will cut to the portions the different bifunctions horns. And if you remember, we studied with you, for example, in the medulla oblongata, do you remember, we studied with you, medially, do you see, were located motor nuclei, laterally than them, do you see, will be vegetative, and distally the sensory. But these nuclei are not located compactly. They are placed by some functional groups, like here, projection to the rhomboid fossa. Do you remember? Because each nerve which begins from brainstem, and brainstem is placed in the cranial cavity, and each nerve which begins from brainstem, do you see, it exits through the openings of the skull. Skull is cranium. The nerves are called cranial nerves. And these nerves will be different by their characteristics. If will be in one place sensory nuclei, the nerve which will begins from them will be sensory. If will be motor, will be motor. If will be sensory and motor, will be mixed by this collection functional. If will be nuclei which are located sensory, motor, and vegetative, will be nucleus, will be nerve which has the same functional characteristics. The all cranial nerves, they are different. Can be motor, can be sensory, can be mixed by different collections. The nerves which started from brainstem, they are called cranial nerves. And we have 12 pairs of the cranial nerves. 12 pairs. Each nerve has its concrete number, which accords concrete name. For example, if the nerve number 1, this is olfactoric or smelling nerve. If the nerve number 5, this will be trigeminal nerve. If the nerve number 10, this will be vagus nerve. If you will inform me, nerve number 9, I will understand this is glossopharyngeal. If you will say me, nerve glossopharyngeal, I will understand this is 9. But we have 12 pairs of the cranial nerves, which have individual numbers, but we have the 13 names. 13 names. If you remember, when I described you projection of the nuclei to the rhomboid fossa, I said you facial nerve by itself has motor nucleus of the facial nerve, and it has some extra nuclei, the salivator superior and solitarius. This will be for the trigeminal nerve. For the intermedial nerve, for the intermedial nerve. Intermedial nerve, it goes together with facial. Facial will exit outside, intermedial will lose its branches by its traveling inside in the skull. Did you understand? Also, look please here. Each spinal nerve is mixed. Each spinal nerve is mixed. And the body of the sensory portion is placed in the spinal ganglion. All cranial nerves, which include sensory portion, they have location of the body of the afferent neuron outside from brainstem. You can see spinal ganglion is placed outside from center near the spinal cord. All nerves, which include the sensory portion, they will include the bodies of the afferent neurons, which complete into the special ganglion, which will have the special name and will locate outside from brainstem. For example, do you remember we studied with you trigeminal depression on the tip of the pyramid? Do you remember? Here is placed trigeminal ganglion, which will be analogist of the spinal ganglion for the trigeminal nerve. Another will be in other places we will study. And listen to me. I said you if the nerves includes the sensory portion, the sensory portion will have location of the bodies of the afferent neurons in the special sensory ganglions, which have special names for this nerve. Except first and second pairs of the cranial nerves. First pair of the cranial nerves is the olfactoric or smelling nerve. The second pair is the optic nerve, vision nerve, optic nerve. Listen to me. If you remember, when I described to you the development of the brain, I said you brain passed through the two stages of the development. Stage which are called the 3 balance and stage which are called the 5 balance. The second stage, from which will develop diencephalon, do you remember? In front will be telencephalon for the hemispheres, after that will be diencephalon, and after that will be mesencephalon, after that metencephalon and myelencephalon. From diencephalon will exit the portions of the nerve tissue. Some pieces of the nerve tissue will exit, by development from diencephalon, and around them will be formed paracardalis and precardalis. This is cartilage plates. Cartilage plates. Later, these cartilage plates will complete into the walls of the orbit, will ossificate and will do walls of the orbit and walls of the nasal cavity. Because the first and second pairs of the cranial nerves, they don't have ganglions and they don't have nuclei in the brainstem. They have concretely the subcortical centers, to which information will come in from smelling or from vision organ, and will come to the subcortical centers for the some special fast reactions before visit of the vision or smelling to the cortex. Did you understand? Subcortical centers, they will do the very fast answer for the visit of the vision before its visit to the cortex. I said you why they don't have ganglions and why they don't have the nuclei. Because they exit and they complete it in the organ. Did you understand? You can see the first nerve, is olfactoric nerve. I will draw the scheme. I will continue my scheme from, left lower to the right upper part. This will be nose. This will be nose. You can see inferior nasal meatus, medial nasal meatus, superior nasal meatus, inferior, medial, superior. This will be cribriform plate. This will be cribriform plate. Here will be base of the brain. Here will be olfactoric bulb. Do you remember I studied with you? Olfactoric trunk. Do you see this on the frontal lobe, on the base? You can see olfactoric bulb, olfactoric trunk, which will contain by olfactoric triangle. Here will be the beak of the callosum body. This will be trunk. This will be pillow of the callosum body. This will give cingulum gyrus, which by bridge will contain into the parahypocamp gyrus. Parahypocamp gyrus will end by ulcus. Here from inside will prominence, dental gyrus. You can see this will be olfactoric triangle. This will be subcallosal field, and here will be anterior perforant substance. You can see here will be, do you see, the lateral groove. Lateral groove from medially will continue to the lateral side. Here will be thalamus, concretely thalamus. This will be mammillary body, which will continue inside into the hypothalamus by fornix. Here the fornix will direct, do you see, to side and will come, do you see, into the medial side of the temporal lobe and will come into the parahypocamp gyrus. Here between fornix and callosum body will be septum pellucidum, transparent septum. Transparent septum. You can see in the, if you remember, when we studied the nasal cavity, we studied the nasal cavity divided into two functional regions. Respiratory, this will be inferior nasal meatus, and superior, which directly opens into the pharynx. This is respiratory, very direct way of the air by inspiration and by expiration. In the superior nasal meatus, which is placed very up, very deeply, and here are placed the, do you see, smelling receptors. Smelling receptors. From smelling receptors begin dendrites, which, do you see here, in the mucous membrane come to their bipolar bodies. Bipolar bodies. Do you see, this will be first neurons of the smelling way. You can see axons from, do you see, bipolar cells will complete by group into the philas. One phyla, one thread, will include many, do you see, axons, and will pass, do you see, through the cribriform plate. Will pass through the cribriform plate. These are called olfactoric philas. Olfactoric philas, which are formed by axons, they will come into the olfactory bulb. By your vision, you can differentiate. If this is expanding, its inside includes gray matter. You can see it, do you see, brings, do you see, the smelling information into the olfactoric bulb. And here, by synapse, will give this information to the second neurons. Axons of the second neurons, they will do olfactoric tract. Olfactoric tract divides into three portions. One will go into the gray matter, which is placed inside of the subcallosal field, subcallosal area. Another will go inside into the olfactoric triangle, and another will go inside to the gray matter of the anterior perforant substance. Here, do you see, will be bodies. Here will be bodies of the third neurons of the smelling way. My dear, do you remember I said you, for us is very important organ, this sensory organ, this is vision, because we get more than the 80% of the information around us by vision. For the different times of the development, for different stages of the development of the animals, was very important smelling. Because I said you, to find the food, to run out from fire anywhere, to find children, to find the opposite sex person, do you see, and to run out from another animals, was very important smelling. Yes? Because this smelling passed through the very longest phylogenesis, and because, do you see, we include in our brain many, do you see, subcortical centers. At first, these bodies of the third neurons, this will be primary subcortical centers. For what? Because from each center, by special its way, information will come to the cortical center, which is placed in the uncus. From subcallosal field will go, do you see, the line, which line is called stria, which by cingulum gyrus, by parahypocamp gyrus, will come into the uncus. If we will look at the medial side of the brain, very medially is placed cingulum gyrus. Yes, very medially. And do you see, it will go, do you see, from subcallosal area and will go, do you see, by medial direction into the uncus. It's called medial stria or medial line. You can see from anterior, from olfactoric triangle will begin a way which passes through the septum pellucidum into the fornix. By fornix will come into the dental gyrus and into the uncus. Look please here. Fornix begins medially and do you see, and goes so to side for the visit into the uncus. Because it is called intermedial. Why it is called intermedial? Because one will be medially, another which I will explain you laterally, and it will be between them. It's called intermedial stria, intermedial line. And another, do you see, Sharuk, show us please the lateral groove which begins on the basal side and how it goes laterally. Between frontal lobe and between temporal lobe, show us. Shahrukh, go to this.
They again didn't put, madam, the organs.
Lateral groove. How it come?
Yeah.
Shahrukh.
Here,
Shahrukh. Base of the brain. Where is lateral groove?
here, ma'am.
To the occipital region, lateral groove. My dear. Show again, normally. Show from base to the lateral side. No, go to the lateral side. Repeat again. This is on, do we see, right side. Show on opposite, on left side. This is lateral groove. Look please here. This is frontal lobe. This is temporal lobe. Between them is lateral groove. If we will open lateral groove, inside is insula, island. Did you understand? And you can see from olfactoric triangle, show us. My dear, do you see triangle? Shahrukh. This is, no. My dear, do you see how the trunk expands and does triangle? Shahrukh.
Somebody come and show.
Shahrukh, stand here, please. Olfactoric bulb, show me only olfactoric bulb. This is olfactoric bulb. Show me trunk. And do you see another smaller triangle? And behind of the triangle, you can see this is anterior perforal substance, very distal part of the triangle, very widest part of the triangle. Show me, please. This is anterior perforal substance. Where is anterior perforal transport? It is near the lateral groove. Did you understand? Show again. No, like here, okay. Because triangle is triangle and its back abnormal. It is the anterior perforal substance. Listen to me. You can see frontal lobe. Here will be anterior perforal substance, and from which laterally into the uncus. By, do you see, insula. Here will be insula. Do you see, is in the lateral groove. Will go lateral stria. Come on. You can see olfactoric trunk divides into three portions, which will go to the bodies of the third neurons. These bodies of the third neurons, these are primary subcortical centers. For the direction to the cortex, to the smelling cortical center, the smelling information by different ways. If the one way will be destroyed, you can see another ways will bring information and animal will live. Did you understand? You can see from the subcallosal area by cingulum gyrus, parahypocamp gyrus, the information will come into the uncus. This is called medial line, medial stria. From olfactoric triangle through the septum pellucidum fornix dental gyrus will come into the parahypocamp, into the uncus, intermedial stria. And directly to side from anterior perforal substance through the insula into the uncus will go the lateral striae. This is, do you see, these are ways which inform cortex about smelling, and cortex does concrete differentiation of the air. Do you understand? But besides this, we have the secondary subcortical centers. Secondary subcortical centers, they are for some special functions. For example, from anterior triangle I don't see the caps. The caps are different. Okay, you can see from anterior triangle. So from anterior, from olfactoric triangle, impulse will come. Do you see into the anterior tubercle of the thalamus? Into the anterior tubercle of the thalamus. Into the anterior tubercle of the thalamus. For what? Do you see? For the primary emotions. For example, you open the door into our room, and here is very concentrated formally, and you do the primary emotions. In some sequence, the cortex will increase or decrease or stop them. Did you understand? But from anterior triangle, by last time we studied with you, exit, do you see, a medullary stria of the thalamus, which enters into the habenular triangle. Do you remember? This will be secondary and this will be tertiary center. This tertiary center for what? For the direction of the impulse, do you see, to the anterior horns of the spinal cord and to the muscles. For example, we took any bottle with ammonia, for example, and we do the smelling start reflex. Do you remember vision start reflex, hearing start reflex, and this will be smelling start reflex. This will be smelling start reflex. Another, if you remember, inside in the temporal lobe is placed, do you see, amygdaloid nucleus. You can see from, do you see, anterior peripheral substance to the amygdaloid nucleus through the insula will direct, do you see, the way. The amygdaloid nucleus is secondary subcortical center. Anterior tubercle of the thalamus is secondary subcortical center. Amygdaloid nucleus for what? Do you remember I explained you? Amygdaloid nucleus, it controls the internal organs, and also it is smelling, do you see, organ. For the control of internal organs, every time it gets information about the condition of the internal organs. And I gave you information about uterus. Uterus gave for it, do you see, information about its condition, and once is pregnancy, and it gives new information, and amygdaloid nucleus answers by some abnormal smelling by any time, do you see, of the pregnancy of the woman. And in some time late it will adaptate, and these abnormal symptoms will finish. For example, I said you women cannot smell the cooking of the some food, do you see, or some women like the smell of the petrol of the something. Did you understand? Do you see? This is connection of the primary centers with secondary. Secondary will be, do you see, in the, do you see, anterior tubercle of the thalamus, in the, do you see, amygdaloid nucleus, and here will be, do you see, tertia for the production of the smelling start reflexes. But you can see we have opposite way. From uncus, do you see, from uncus, do you see, through the parahypogam gyrus into the fornix, and from fornix into the mammillary body, will direct opposite way. From mammillary body to the thalamus will be mammillothalamic way. Mammillothalamic way for what? For the correction of our primary emotions. Thalamus did primary emotions. From cortex after analysis, this information through the mammillothalamic way will come to the thalamus and will decrease or increase our emotions. Did you understand? This is first pair of the cranial nerves. Did you understand? The second pair of the cranial nerves. You can see, I said you, here, do you see, will be some millions of the neurons, do you see, because, do you see, they exist by development from diencephalon. Do you remember? You can see second pair of the cranial nerves. Second pair. Optic nerve. Optic nerve. You can see, here will be my right eye. Here will be my left eye, like I stand in front of you. Do you see? You can see this will be pupil, this will be pupil, and here, do you see, will be object. Synhil and tavia, да? Synhil and tavia. Oh, my dear, I will take my right eye. Synhil, do you see, it sits medially than my right eye, by my this position. Tavia sits medially, do you see? And synhil has projection, do you see, to the medial retin. Tavia, do you see, has projection to the lateral retin. Listen to me. Retin is formed by 3 layers of the cells. When we studied the eye, I said you. Very internal layer which contacts with light. It is formed by rods and cones, do you see? This will be unipolar cells. And they are unipolar cells and they are, do you see, receptors by same time. But this will be the first neuron, unipolar cell of the vision way. They are very micro axons. They connect with do you see, second layer. Second layer is formed by bipolar cells. This will be bipolar cells, do you see? Bipolar cells, by their axons, do you see? They contact with multipolar cells, which complete into the third layer, This will be multipolar cells. Did you understand? The 3 neurons, do you see, by micro distance of the axons, they connect with, do you see, second layer, which is completed by another neurons. And from multipolar cells, and do you see, all cells, they are placed only behind of the equator, because the light cannot rotate, it can go only behind of the equator. And you can see, from multipolar cells to the posterior polar will complete the nerve. This will be optic nerve. But medial part of this optic nerve, will bring information about lateral position of the synhil. Do you see? The lateral part of the nerve will include information about tavia, which sits medially from my right eye. You can see from medial retin about a lateral object, do you see, of the right eye, do you see, information will come to the left hemisphere. From, do you see, lateral retin about medial object, do you see, information will come to its hemisphere. Did you understand? On this side, on this eye will be the same. From medial retin, do you see, information, do you see, will come, do you see, to the opposite hemisphere than the, do you see, side of the eye. From lateral retin, do you see, will come, do you see, to its hemisphere, Do you see? This, do you see? This is called optic nerve, which passes through the optic canal. From orbit, it exits by optic canal. Do you see? The medial portion of the optic nerve will pass through this groove to the opposite side. the lateral portion will go to its side. From this, the medial portion will, by this groove, cross to the opposite side, and the lateral will go to its side. You can see this is optic nerve, this is optic chiasm, and this is optic tract. This is optic tract. Do you see? Optic tract includes information from both eyes. Do you see? My dear, I want to recollect you the following. Here, do you see, is chiasmatic groove, sulcus chiasmaticus. Here you can see position of the optic chiasm. What is optic chiasm? Optic chiasm started from medial retines about lateral objects. Behind of the optic chiasm is thoracic saddle. In the center of the thoracic saddle is placed pituitary gland. If will be cancer or tumor pituitary gland, if will be tumor, it will press the optic chiasm. If will be cancer, it will eat the optic chiasm. And students will lose lateral vision fields. For example, I see here, and I look at you, do you see? And I see thin heel, and I see all another persons, and I see the bilateral vision, I see, do you see, opposite wall. If will be distraction, do you see, I will see only in front of the me, and for the, do you see, looking at thin heel, and for the looking of this our girls, do you see, I must rotate my head, do you see, because we will lose vision fields. In the ophthalmologic hospital, you will see, do you know the ring for the, I forgot, velocipede. I forgot by English name.
Bicycle.
Bicycle, yes.
Bicycle.
Bicycle, do you know? Two rings, yes? Bicycle. Yes. And listen to me, do you know the ring for a bicycle? Do you see, we will cut the half, and we will see the one, do you see, half spheroid part. And on the distal part of this, do you see, half spheroid part, we will mark the red pointing. And the doctor will change position of it and will draw the scheme of your vision fields. Did you understand? No, you will study this. Listen to me. Here we had the what? Optic tract. Optic tract. This will be optic tract. Listen to me. What our olfactory tract did? What our olfactory tract did? It divided into 3 subcortical centers. Here, do you see, will be superior colliculus of the tactile lamin. These are elements of the what? Medial brain. This will be cerebral pedunculus. This will be cerebral aqueduct. This will be tactile lamin. Do you see? Superior colliculus. Superior colliculus. Do you see? This will be pulvinar of the thalamus. Do you remember? I draw you the vision center. And this will be lateral geniculate body. Lateral geniculate body. And here will be the, do you see, medial side of the occipital lobe, on which will be calcarine groove. In the borders of the calcarine groove is vision center. Did you understand? Cortex, which does differentiation of the vision information. You can see one portion of this tract will come into the pulvinar of the thalamus. We'll do you see, the synapses, and after that we'll go to the cortex. Another will come, do you see, into the lateral geniculate body. For what? I direct to the cortex only important vision through this moment, not about lamps, walls, and all another. This will be differentiation. And another portion will come where? Into the superior colliculus. Do you see? From superior colliculus will come where? Do you see? For the vision start reflex. For the vision start reflex. Do you see? For the vision start reflex. for the vision start reflex. Do you see? But if you remember, here we have oculomotor nucleus, do you see? And here we have accessory nucleus of the oculomotor nerve. And here we have intermedial median nucleus. Oculomotor nerve by itself exits, do you see, from brain by interpeduncular fossa, enters into the orbit by superior orbital fissure. And here it will come, no, we will, do you see, inform later to what it comes. Do you see? Vegetative nerves, they don't go alone. They take the transport, and by this transport will enter into the orbit. Did you understand? Through the superior orbital fissure. Vegetative nerves, they don't go alone. They travel to their objects by somatic nerves or by vessels. If, do you see, we don't have somatic nerves and we have any vessel which supplies the organ, the vegetative nerves will spread, will donate around of the vessel, which will have the name plexus, for example, ophthalmicus. Do you see? Which vessel will come to the organ, the same name will get the nerve net which covers this vessel. Did you understand? You can see, but here is interesting moment. Nuclei, all nuclei, this will be, this nuclei will call vegetative centers, this nuclei will be somatic centers, do you see? And from center, the all impulses will exit with same velocity. I push Ankita by needle, she will do reflex, do you see? If I will direct light to my eye, this will be a velocity of the closing. Vegetative nerve system comes to the organs, vegetative impulse comes to the organs, and you know the vegetative nerve system, it controls smooth muscular tissue, it controls the secretion tissue, whole smooth muscular tissue and whole secretion tissue, and also myocardium. Smooth muscular tissue, this is, for example, is, do you see, sphincter pupil muscle. Smooth muscular tissue, it completes into the walls of the digestive tract. Esophagus, stomach, intestine, did you understand? And you can see, by somatic nerves, impulse exits with very fast velocity. By vegetative nerves from center will exit very fast velocity. But it cannot come with very fast velocity to the, for example, intestine. Because smooth muscular tissue of the intestine, what does? Peristaltic movements. Yes? And listen to me, if impulse will come with velocity 120 meters to the intestine, will be peristaltic movements. We will live, we will sleep, we will study in the toilet. Because very fast peristaltic movements. Another, do you see, I said you also, no, like exception myocardium, because it by some characteristics look like smooth muscular tissue. Myocardium. The blood cannot enter, cannot exit. Very fast velocity. Because impulse from center by vegetative nerve system comes to its objects, do you see, through the stations. In the stations will be decreasing of the impulse. How it will decrease? Now, for example, here, do you see, we have the accessory nucleus of the oculomotor nerve. What is nucleus? This is collection of the some thousands of the bodies. Yes? We will take only one body from this, do you see, nucleus, one body. This will be its axon. Its axon comes to the station, and do you see, each from this collection will come to the station. This station will be special vegetative ganglion. It is different than the sensory ganglion. It is placed on the way of the impulse from center to the organ. And this ganglion, it is covered by capsule, and inside will be many thousands of the nuclei. Each axon will subdivide to the terminal ends. which will do individual synapses with individual cells. When the one, do you see, axon divides into the many ends, and each end will do individual synapse, this is called multiplication. One axon divides into the many, do you see, does many synapses. Do you see? This is called multiplication. You can see this axon brought the big pocket of the order. And this cell took the some smaller portion, this cell, this cell, this cell, this cell, this cell. And do you see? And they each, do you see, cell by its axon will bring, do you see, order to the any group of the myocytes or to the any group of the secretion cells. Do you see? These are called pregangliotic fibers. These are myelin fibers, which bring the impulse with very high velocity, near the 100 meters in 1 second. And here will be postganglionar fibers after ganglion. They will be without myelin sheet, because do you remember on biology you studied the nerve system of the hydra. And nerve system is nerve system which is formed by tiny nerve fibers which are without myelin sheet, and they, do you see, they direct impulse with very smaller velocity. Vegetative nerve system, it consists in its structure many stages of the development of the nerve system, do you see, through the phylogenesis. You can see this is multiplication. You can see here in the orbit is placed vegetative ganglion, to which this motor portion will bring impulse, and after that, by very smaller velocity, will come to the sphincter pupil muscle, because this sphincter pupil muscle will contract slowly. Did you understand? You can see you can see, oh my dear, from, do you see, colliculus, do you see, will direct impulse to the, do you see, accessory nucleus of the oculomotor nerve. For what? For the production of the pupil reflex. Did you understand? You can see here I will separate my right eye and left eye, and I will direct light from lamp on my right eye. Here I will have contraction of the sphincter pupil muscle, and here also. Because each colliculus, it contacts with, do you see, its nucleus and with opposite nucleus. Do you see? This is common pupil reaction. This is common pupil reaction. And another, you can see here, intermedial median nucleus. It is unpaired. It is median. Listen to me. Here will exit nerve. Do you see? And here exit nerve. You can see vegetative portion. Vegetative portion completes, do you see, here, from the nucleus, and from same nucleus will direct, do you see, here. You can see this is vegetative portion. Again, will come to this, do you see, cells, will do multiplication, and after that will go to the ciliar muscle for the accommodation. Look at me. I will look, for example, in this table, at this table, do you see? And do you see, I want to read the book. I must have the some sequence for the adaptation, accommodation. Do you see? And I do accommodation, do you see, by both eyes, because this is one nucleus. I said you, it's not like in students' nucleus, because they want to look by one eye at teacher, by another eye at a book. Not, because this is one nucleus, and we can look by same moment at teacher, do you see, by both eyes, and at the book by both eyes. You can see the impulse by, do you see, optic tract came, do you see, into the superior colliculuses of the tactile lamin, for the production of the vision start reflex, for the production of the pupil reaction, for the production of the pupil reflex, for the production of the common pupil reaction, and for the production of the accommodation. For the production of the accommodation. Did you understand? And olfactoric tract directs, do you see, into the pulvinar of the thalamus for the primary emotions, and into the lateral geniculate body for the differentiation of the vision information, and from thalamus and from lateral geniculate body will come for the concrete analysis into the cortex. Did you understand?
Do it here, ma'am.
Trigeminal next time 1. This is nose. Nose is only specially for the orientation of the side of the eye. Do you see? This will be eyeball. This will be upper eyelid. This will be pupil. This will be iris. This will be this is medial brain.